All right, so we can get started here. Thank you everybody for coming out this morning. My name is Daniel Dodgson. I'm the Data Engineering Manager at Geotab, and this is my colleague Bob Bradley, who's the Data Solutions Manager. And today we're going to talk to you about leveraging big data within your business. All right. Already got problems? Cool. All right, so some of the key points of what we're going to talk about today is, first and foremost, let's just kind of get everybody up to speed. What is big data? I know there's a lot of different, big data has been around for a bit, a lot of different definitions, but we'll just give you a synopsis of what big data is to us at Geotab. Secondly, we'll go through how we at Geotab leverage big data. I know Neil spoke to it a bit during his keynote speech, and we'll just elaborate a little bit more on that. Secondly, we want to tell you guys how we can help you get started with that big data environment. And then thirdly, we'll go through is how you can start to leverage that big data environment that we help you get started. So what is big data? So at Geotab, we've adopted the concept of describing our big data environment as a data lake. So like I said, I know there's a lot of different definitions and terminology around this big data realm, but a data lake in essence is a very large data repository for your raw data. So the data flows in from different streams into this data lake and almost immediately becomes usable, accessible to users to start examining, sampling, or just dive right in. There's a lot of value in every piece of data that we collect at Geotab, and it really comes down to just knowing how to extract that value from the data. So this I'll touch on in a little bit in a couple slides. But first let's look at our infrastructure. So our big data environment, what we use on the back end is Google Bigquery. Google Bigquery, it's fast, easy to work with infrastructure. It gives us a lot of flexibility in terms of how we ingest that data into Google Bigquery. It's a cloud-based platform, so it's accessible from anywhere, and it's easy to integrate with many different analytical tools. Some of the tools we use are Dataflow, Kubernetes, and Airflow. So these help us with data processing, data enrichment, and scheduled ETL processes to help us understand our data. Some of the other tools we use, we really work closely with Jupyter Notebook platform, so tools such as Data Lab or Colab. And this is in order to assist in helping us do data analysis, data manipulation, and tackling complex machine learning problems. So how do we use this data that we collect now at Geotab? So a couple examples just go through. So the obvious use case for us is in our telematics data by creating informative and engaging data sets. So one way we've done this is by creating aggregated data sets related to weather, urban infrastructure, and location analytics, which will soon be available to everybody on data.geotab.com. Another example is seen in the vehicle vocation classification, where what we do is we look at the driving behavior or driving pattern of vehicles, and we're able to predict what type of vocation that vehicle belongs to. There's a talk on this later this afternoon called Benchmarking Your Fleet. If this is something you're interested in, I highly recommend checking it out. But with all that being said, Geotab's big data environment isn't just about the telematics data. That's the fun stuff that we get to work on. But there's a lot of other data that we have in our big data platform. So we collect data from all areas of the company, and it allows us to draw insight from everything that's going on at Geotab. So we ingest security logs from not only our servers, but from our employee laptops, and this ensures that we keep to complete security compliance within the company and allows us to identify any potential threats that are happening. We upload tester logs from our production environment so we can see where devices are in the manufacturing process, so we can see if there's any issues or delays, and we can plan for that accordingly. We also upload server metrics, which allow us to keep optimal uptime on our My servers and monitor these servers in order to prevent any issues such as CPU performance or memory issues that may occur. So obviously, this is a lot of different data from different departments. So what we do is we actually have different specialists in each department that are responsible for looking at this data so that we can ensure that the right people are looking at the right data. So you're probably thinking, this is great, this is awesome, but how does that help you with your business? Well, at Geotab, we want to help you guys get started with your big data platform. And the way that we want to do that is through a product called the Data Science Package. So the Data Science Package is a platform that allows my Geotab customers to have an isolated Google Bigquery project that contains all of your telematics device data. We'll also push curated data sets that we've created on your behalf, and will also give you easy access to Geotab's intelligence datasets, so the ones I talked about earlier, weather, urban infrastructure. The data science package, it's going to be an add-in that we are going to be releasing in the next couple months. That when it is enabled, it will initiate a process that will create a project for you in Google BigQuery that we will host for you. It will allow you to give access to specified users via the add-in, so you can add whatever users you want to this BigQuery project. And what it does is it also has automatic nightly transfers to upload your previous day's data into Google BigQuery, so that you can always keep up to date with your fleet's data. So analyzing and driving insight from large volumes of data is obviously very complex. Therefore, this data science package is geared towards larger fleets, fleets in the 500 plus devices, in order to help integrating vehicle data with other lines of business systems to make things more streamlined. So a couple examples of how we're helping you guys get started with this is with curated datasets. So what we'll do is we'll be uploading things like your harsh events for your fleets, exceptions, your MyGeotab trips, and the vehicle vocations of your fleet. What I kind of believe is the bread and butter of this environment is the interpolated data. So what we do is we'll upload your accelerometer and engine data, such as your status and fault, and we interpolate that with GPS data. So what that means is we basically assign a location to every one of these logs when we push it into Google BigQuery for you. So it saves you the time and effort of having to figure out where these events are actually happening. The other thing that we do for you is we interpolate the GPS data. So this means we actually give you 10-meter resolution on your GPS data. And what that does is that gives you obviously a lot more high resolution on your data and allows you to understand what your vehicles are doing at various points of time. What we will also be doing is providing some Python notebooks, some SQL code, and some how-tos in terms of how to get started working with the data. So really, all you need to, with this data that we're providing you, all you need to be able to do is start writing some simple SQL queries, and you can get up and running. So just as a quick kind of example, these are a couple things that we can put together just from that interpolated data that we give you. So taking your status data, you can simply look at your temperature tracking. And because we've enriched it with that GPS data, you can just plot it on a map, and you can easily get this information in seconds. That's the beauty of Google BigQuery. Same with something, for example, like your winter operations. That comes in as status data. Because it's interpolated, you can just throw it on a map, and you can get this easy integration in terms of understanding what's happening and where what those vehicles are up to. So how does this whole thing work? Like I said, it's simple to get started. It's a data science package is an add-in in MyGeotab. You go into the add-in, you enable the data science package. Once it is enabled, it will take several minutes to kind of kick off the initialization process. And the reason it takes a little bit of time to get going is because what we're doing is we're actually creating the whole project for you, but we're also uploading all of your previous days worth of data, so that as soon as you log in, you have something that you can start working with. Now, later on that evening, what we do is we will actually upload your a full year of historical data for you, so that now you can start drawing full insight from your fleet and what they've been doing over the past year from the data in Google BigQuery. This is just an example of that enriched data that I was talking about. So this is just a screenshot of Google BigQuery, but what you can see is this is your status data, and we've enriched it with latitude, longitude, geohash, and speed. So you can draw instant insight from that data with just, like I said, some simple queries. I'm now going to pass it over to Bob, and what he's going to do is he's going to talk through how you can start to leverage your new big data platform.
Thanks, Dan. Yeah, so as Neil talked this morning, if anyone got the opportunity to hear him speak, you know that we use big data internally for everything. The company runs on big data. And since we're developing this data science package, we've had the opportunity to kind of play with it and tune it internally. I'm going to talk to you a little bit about some of the stuff that we've been able to do, some of the ideas we have on how you can use it, and give you some quick examples of how it could add some value to your business. So the first thing that I want to mention, and Dan already covered this, is that this is really the start of your data lake or your customer's data lake. By kicking off a BigQuery project with your data, it's the start of something that could ingest data from other sources. One of the things we love about BigQuery internally, and one of the reasons we continue to use BigQuery, is because they have easy development support. They support multiple languages. There's Python, .NET, JavaScript, you name it, you can interact with BigQuery. And it's well documented. Google has excellent documentation around that. And the other thing that's really cool about Google BigQuery is because we're using one of these large platforms that has a ton of backing, there are visualization add-ins that you can use. It may be something you already have, it may be something you can roll out, but there's visualization that can plug in and you can use it right away. So one of the ones that I wanted to just showcase a little bit, and I apologize if it's hard to see from the back of the room, is something we use internally at Geotab for some of our metrics, and it's a platform called Redash. And what's important about Redash is that it's an open source platform, so it's free to use. There's no seat license, and it works really, really well with Google BigQuery. So we crunch through a petabyte of data at Geotab, and we create dashboards, and we do all of those magical things that Neil talked about this morning. But I took the time, and I had a sample of the data science package set aside for myself, and I put together a few charts just to see what I could do in about 30 minutes, 45 minutes. So on the left here in the top, I have the stop time distribution and the drive time distribution for my fleet. And you might be saying, what's the big deal? I could do that probably already. But imagine this is a fleet that has a year's worth of history with a couple thousand vehicles. That's an awful lot of data. In fact, one of the case studies I'll get to later produces about 60 to 80 million trips a year. And so, that's an awful lot of things to crunch. And starting with something like this allows you to manage by measurement, because if I look at the long tail there, I can actually slice off the long tail, figure out where I'm spending most of my time or where I'm waiting longer, and I can use the GPS data to figure out, is that a location is it an office location? Is it a warehouse? Is it a customer? Is there something I can change in my process to fix that? The other thing I can do at the bottom here is I can actually dig into individual vehicles, and I can manage by measurement there by looking at exceptions or idling percentage or whatever metrics are important to your fleet. One of the cool things you can do with Redash is you can link these things together, so I can actually click on one of these vehicles and be taken to some other dashboard. So I can dive into my data, which is something I think is very, very important. And finally, on the top right there was just me playing around with some idling data. And what's really, really cool is that I can see this is some of the data here in the Toronto area. So obviously the winter here, for those of you not from here, is a little colder than it is out there today. And you can see that there's a spike here in idling. So that kind of purple red line there is idling. So in the winter, we idle a lot more here, this particular sample that I put together. And I can actually plot on a map and see where those locations are. So where am I idling? Again, is it a warehouse? Is it someone idling at home? And I can take a look at that and see it on the map. And again, 10 vehicles or a couple months worth of data, maybe not a big deal. But looking at an entire year's worth of data, thousands of vehicles, and being able to do this in a few minutes is pretty powerful. Another tool that I just want to quickly touch on, because I think it's pretty important to the data science package, is Google's own tool, Data Studio. So if you've never had a chance to play with this tool, it's pretty amazing what you can do. If you've worked with Google Docs or Google Sheets, you can work with Data Studio. So this took me about 20 minutes off that same data. What's in the charts isn't terribly important, but I'm looking at fleet composition. I'm looking at a utilization score that I came up with for my fleet. And all of this stuff is done on the web. So there is no infrastructure for you. So we've provided you with a Google BigQuery repository. We're giving you the tools, or we're suggesting some tools here that you can use. And I have literally set up, and there's no DevOps, there's no servers, I'm not running anything. I'm just using these tools that are out there that are scalable. And this one's really cool in particular because it renders as a report. So you can make it multi-page, you can export it to different formats. And so if you're looking at this and you want to deliver a monthly report, you can do that. And if you want to dive into your data and filter it, you can do that as well. So again, another tool that as soon as the data science package is ready, you can get going right away. And so, you have this Geotab data, and I could probably talk to you all day about things you could do just with the Geotab data alone. And in fact, if you want to find me, I'll be out on the floor, and I'm happy to chat. But really, the power comes in when you start blending this with other pieces of data. Neil talked about it, Dan talked about it, and when you start mixing and matching your Geotab data with other line of business data, that's where we see the real power. So it could be maintenance logs, or routes, or stores, or distribution centers. It could just be weather data, or something from data.geotab.com. I'm happy to chat about that on the floor as well. And what can happen here, so if we take a couple examples, and I'll walk through a couple of these quickly. So if I'm a retail store business, I have store locations, and I bring those locations into the data science package. So I upload my locations into BigQuery. Now I can create zones around those stores, and I can do some pretty powerful stuff. And one of the things that I might do, and I'll talk about our case study later, and they did something like this, is if I have thousands of stores and thousands of vehicles, what might be important to me is concurrent utilization at one of those stores. So if I have my Geotab trip data, and I have my store locations, and I create zones around those, just through queries, I can figure out what is the availability of the vehicles at this particular store. So I can assign a store to a vehicle by where it rests, and I can look at when they travel in and out. And if my business relies on quick, on-time delivery, then I have a problem right here, because from 1 o'clock to 2 o'clock, I don't have any vehicles available. So I may need to ride share, I may need to buy a vehicle, but this is an insight across all of my business, and it may be one store out of hundreds that I can find, and I can find that in seconds. And I can do the similar thing with customers, but another cool thing that we find with customers, and we've done this for a few people as well, is that you don't always get the optimum location for your customer. And a good example of that is a golf course. So this is a golf course near our office. This is Glen Abbey Golf Course. And if I punch in an address, maybe I have the address correct, or maybe one number's off, I actually get a location on the road. And that might be the entrance to the golf course, or it might be the entrance to a plaza. But oftentimes, you're not delivering a product or a service at the entrance to a golf course. You're doing it 2 kilometers down the road at the clubhouse. And so if I bring in my sales transactions, or my planned routes, and my customer addresses, now I can combine this data in an interesting way. So I can create zones around my customers, just like I did with my stores. And I can actually infer when I went to a customer based on either a route or a sales transaction. So if I know I always deliver to the golf course every Monday at 1 o'clock, I can now look at my Geotab vehicles and figure out which ones went close to the golf course at 1 o'clock. And if I do that, and I cluster that data, and I look for a pattern, and I filter out some outliers, a few steps, and we can provide some of these steps through our Python packages and our sample code, I can create a nice, tight, bounding box around the exact part of the golf course that I service. So if I'm delivering product to the clubhouse, great. If I'm doing some services to sprinklers or the lawn, awesome. I can put a box around that, and I can feed this now back full circle into my Geotab to take advantage of the rules. Again, something that's possible by combining some line of business data. And I can also use that same data now, the sales transactions and the customer locations, to figure out what is my time to serve. Is that important to me? And is it different in different parts of the country, in different countries, with different fleets? I can slice and dice the data and really figure out what does the distribution look like. Do I want to manage the long tail and figure out where I'm missing it? Or do I want to focus in on the ones that are working well and figure out what I'm doing well? And the other thing, again, with this same data set, is I can figure out what is the delivery pattern of my fleet. So now that I've inferred my store locations and my customer locations, I can start to look at what is the driving pattern. Do I hotshot stuff out if I'm a delivery company and I'm one and done, I'm out to a customer and I'm back? Or are my successful locations doing multiple customer visits as they drive around? And how are they doing that? And do I have the tools in place to enable people to do that? Do they do something different when they're doing multiple customer visits? I can answer all of these questions. And I can also take a look at unknown locations, see if people are stopping at unknown locations, and that might be fine, or they might be customers that I haven't yet discovered, or they might be places where I want people to stop going. And all of this stuff will come out when looking at it through big data. Another thing that you'll be hearing a lot about at the conference is data.geotab.com. And Neil touched on it this morning, and I know Mike's going to have a touch on it tomorrow, and you can come find us on the floor. And so we're looking at producing, and we have produced, aggregate data sets in a number of different categories. And I've just highlighted a few here. And this stuff is already sitting in Bigquery. So to use this stuff is as simple as signing up on data.geotab.com and joining this data with your data. And so you might look at hazardous driving areas, and Neil talked about it in his talk this morning, that one intersection might be completely different than another. And you're doing a safety score in my Geotab, and you're measuring your fleet and monitoring your fleet, and you're saying, obviously I'm a much more safe driver than Dan here, but the fact is he might be taking a much more dangerous route, and he might need his score augmented based on looking at something like hazardous driving. And you can join these data sets and do that. Or road impediments, maybe you have very, very sensitive cargo, and you'd rather avoid roads that we see are pretty bumpy. So you can imagine that there's a whole bunch of stuff in data.geotab.com, and we'd love to get some ideas as to how you'd like to mash it up or what data sets we might be able to add in the future. But the point is, once you sign up, this stuff is ready to go. You don't need to do any work. And the other thing that we do a lot at Geotab is we look at open data. So there's plenty of great open data sources out there. And you could consider a lot of our data.geotab.com stuff open right now. It's free and easy to use. But there's census.gov and data.gov. There's shape files. There's you can get state locations, city locations, population, income information, you name it. There's also some really good open weather data. So how does weather impact your business? How does it impact your delivery schedules and things like that? And the cool stuff about some of the weather data is it's also in Google BigQuery. So Google has sourced a number of open data sets and put them inside BigQuery. And again, it's there, it's ready to use, it's free to use, and you can join it with your data as soon as you open up your own BigQuery instance. So I think the message here should be clear by now. It's, we will get you started with the Geotab data. And there is a lot of meat on that bone. There's tons of stuff that you can do with just the Geotab data. But real value and real stickiness comes from leveraging other pieces of information, whether it's something that I've already highlighted or something from this list, repair, gas card information, shapefiles about zones you're interested in, zones from my Geotab, you name it. There's a ton of possibilities here. And I'm pretty excited to see what people will do with this. And before I wrap up, I just want to walk you through an actual case study that we did. So like I said, we've had the good fortune to be able to create and play with some of this data for about the last year. And we actually engaged with a few customers and resellers. And one of the customers was a pretty forward-thinking organization, really interested in furthering their data science. And I think that was a key to this whole process. So together we learned. They have large geographic coverage. They have thousands and thousands of Geotab devices out there in the field, millions of customers, high trip velocity. And like I said, they're a retail customer. So they're distributed out there. They're in and out. They're high velocity. And so we thought, let's try this data science package and let's see what we can do. And this customer was pretty clear. They actually they weren't trying to monitor their vehicles. They weren't trying to look for nuggets of what you'd expect. They had one clear mission statement. How can we leverage Geotab data to understand and augment our customers' experience? So what can we learn from the Geotab devices that we don't know already? And I think the one thing that came out of this is that the Geotab devices are kind of the ground truth. There's many, many systems that you'll see we integrated here. I give an example of 3. All of those things are subject to some human error. And through the Geotab data, through knowing where vehicles are going when they went there, we were able to kind of clean that data and look for holes in processes. So to understand their customer experience, we started with 4 data sets. So at the bottom here, at the bottom of the pyramid is our Geotab data. So again, like I said, if a car goes from A to B, we track it, the time and when it went. And one of the interesting things we noticed, and good for Geotab, I guess, as well, is that parity was pretty important at this stage. So they had so many stores and so many vehicles. If we're going to start layering in other data, they need to have all of their vehicles outfitted with Geotab devices. Because if you're late for a delivery, you're not concerned about which car you're going to pick. And in fact, you may pick the one that's not tracked. I don't know. But it's very, very hard to infer matching transactions to cars when you don't have all your cars outfitted. The second thing we layer on top, something I already talked about, was the location of all their retail stores. So this gives context to the Geotab data. The first thing we can do is give every vehicle a home, so we know which store or which distribution center a vehicle belongs to. Then we layer in their customer locations, well over 1 million customer locations. And we noticed, they did their best effort, but some of those locations were messy. So the fourth kind of key thing here was point of sales transactions. When did people phone in their orders? What store took the order? When did it go out? And those 4 things combined allowed us to do some pretty cool stuff. So we took those 4 pieces of data, and among other things, this is kind of the key stuff that came out of this. So we took the retail locations and we created zones, something I already talked about. So around every single store, we created a zone. Now, some of their locations are pretty large, so we had that golf course problem that I already talked about. Where do the vehicles park when they're waiting for that next order? Is it in the front of the store? Is it in the back of the store? And if I look up their address on a map, I get this, I get it 500 meters away at the corner of a plaza, perhaps. We did the same thing with customers. So we had customer zones, created zones around every customer location as they were provided to us. We got the point of sales transactions, and what was key from that was the time of an order, whether it was ordered by phone, the type of customer, the customer number, et cetera. So that data came in as well, all again back into Bigquery. And then, of course, we had our Geotab data. And what was key in this particular analysis was trips. When did a vehicle start? When did it stop? Where did it go? And one of the cool things we did was we chained trips together until they came back to their home base so that we could know Dan made 3 stops while he was delivering products. Bob just goes out and comes back. There's a difference there, but we know that if we take the time Dan left from the retail location to the time he ended up at a customer, we can track that all the way back to figure out how long a delivery took. And out of this, we were able to redefine a lot of their customer locations and even some store locations. So you have over 1 million customers, you automatically already have a big data problem. We were able to use the vehicles as they travel to continually refine where their customers are. We were able to calculate, and this was the key, true order to delivery metrics for this customer. With so much data, it's very, very difficult for them to track that. They have a point of sale system when someone says, hey, I came back at a certain time, and they're doing their best effort to figure out when they got back. Well, we know exactly when that vehicle got back, so we could calculate true order to delivery time. we were able to take that delivery time and figure out distributions. Now they have this data, and now their eyes light up, and they're slicing and dicing this by location, by store, by state, by country, you name it, to figure out what makes their delivery times different in each of these different scenarios. And we found correlations between concurrent utilization. So what are their hot times at different retail locations? What are the low times? How far do people drive? Does that affect the usage at a location? Should they be looking to move locations, insert new locations, rideshare between locations? All of these were questions that came out after we found the correlations between a store and vehicle utilization. And so what they ended up doing with this was actually pretty remarkable. So they now have automated this process. So they are automating the tracking of order delivery times. They're keeping an eye on that. They're making sure their processes are better to figure out more and more accurate numbers. And they're figuring out, they're taking the outliers and they're dealing with that. They were now, what was most important to them was giving accurate expectations to their customers. So they have a fundamental better understanding now of the driver behavior, of the tools the driver uses. So that allows them to give accurate expectations in any given region, for any given type of customer, for any given type of product that they want to get out the door. And since they understand this, they're now looking at this as a way to maybe turn it into revenue-making opportunities. If they know they can have some new level of service or some different service, and all of this has to be, their fundamental belief is that it has to be backed by data. So if this data shows that they now have an opportunity across the entire company or in one location to have a new way of doing business, then they're going to take that opportunity. And they have an investment in data science, so they are beefing up their team. And their team is playing with this data. Their team is looking at other data sources they can bring in. Their team is actually suggesting changes to the process. So they're looking at better tools for drivers so that they can end up with cleaner, better data as an output of that. So this kind of investment in data science and this kind of forward thinking at this organization is going to fundamentally change the way the customer experiences things over the next year. And all of this is backed by Geotab data, and then layered on top of that is their line of business data. So that's it for the presentation. I know we have a Connect app where we're fielding some questions, and I'll double check if there's any there. And after I get through those, if anyone has any in the room, then we'd be happy to try and answer your questions.
Shapefiles. We're doing a similar project. We have about 120 stores and about 500,000 customers with all our delivery trucks rolling around. We're trying to import all the addresses. We're actually signing we already signed a contract with an outside provider for shapefiles.
Okay.
But unless you have a source, an open source that's free, we're paying quite a bit for all the shapefiles that are available.
So it really depends what you're looking for in the shapefiles. What we have found, is that there are a number of open shapefiles if they're related to census tracts and if they're related to government published information. Some of the cities, City of Columbus has an open data portal where you can get very specific stuff about Columbus. But in terms of something that would be like a customer locations or something like that, I haven't come across any kind of open free data set on things like that. Let me take a look at some of the questions in here. So, is Big Data Geotab team working on their own, similar to firmware team, or is the team actively working with customers, resellers too, similar to solutions engineering? Yeah, that's a good question. So I guess the answer is a little bit of both. So we're always learning. So we're always interested in hearing what a reseller might be able to bring us in terms of, hey, it would be great to have this data, it would be great to have that data. As I said, we did work closely with a few resellers and their customers to kind of pilot some of this stuff as it came up. So I would say we're doing a little bit of both, but largely now as we're releasing products, we've kind of siloed off and done much of our own work in trying to get this up and running. I'd say we're similar to solutions engineering. I think we partner with solutions engineering, and I think a lot of this stuff usually comes through them. So if they identify an opportunity where bringing in someone from the big data team would be beneficial, then I would expect that they'd kind of come knocking and say, hey guys, we have this opportunity, what do you think? It might be answering a simple question, it might be engaging in something larger. So I don't know if that truly answers the question, but the answer is a bit of both, yeah. How can we overlay multiple databases as a reseller for central database management?
So for this, the way the Bigquery platform works is you can query across multiple projects seamlessly. So as a reseller, your customers will have individual projects, but as a reseller, if you have access to each of those projects, you can write queries that hit all those projects as if it were one. So that's the beauty of Bigquery, and that's how you can integrate easily with our data.geotab.com datasets as well. We're not going to push those into the individual projects, but you will have full access to those datasets, and you can query as if they were part of your own project.
So the next one is, to provide big data analysis for our particular big fleet customers, only their data, should we do it 100% on our side, or is there any big data tool that will allow us to bring data from particular fleet/databases? So I think, if I understand the question correctly, that is kind of a similar question to what you just answered. The general structure of Bigquery is that you can query across projects, and so when we're using this tool and you're allowed to enter in levels of access to your project through my Geotab, if it's a reseller that's looking to offer this as a service to multiple customers, they would then need that level of access to be able to go out and get access to individual customer databases, and you'd be able to decide that in my Geotab, and then a query could go across if you're looking for big data insights across a particular vertical or whatever you need to do, but they would be siloed, but there's an ability to kind of work off multiple databases. You want this one?
So as far as I understand, data comes from Stormford server, so it's pure data without customer info such as vehicle or fleet names. With that in mind, how are data sets made when talking about statistics by make model? Is this only applicable for those vehicle getting VIN from CAN? So yes, data does come from the Stormford server. How do data sets made when talking? So part of that data is the VIN data that we get as well. So yes, only the vehicles that are actually transmitting VIN, we will have VIN for. Vehicles that we're not actually recording the VIN for, we won't have that information. There's not much we can do. And that would be no different than in my Geotab. In my Geotab, if you manually input your VIN, that's great, but we wouldn't get that in Bigquery. So it's really only what's coming from what we get from the device itself.
I think that's the last one.
That's the last one, okay. So is there an SLA applicable for Geotab datasets? So for...
I think not today, anyways. We are still a few months out from rolling out the product, and as far as I know today, I'm kind of glancing over at Mike here, there is no particular SLA available for this, but again, happy to discuss on the floor if someone wants to dig in, whoever submitted this wants to dig in further, because we are, this is a near future type thing. It's not quite ready yet, so this may be something we have to think about. Anyone else in the room have a question that didn't submit it through the app?
How are you accounting for drips? So I know, for example, trips can update 2 to 3 days later. Are you guys accounting for that?
Yeah, so when we do the day before's data, it's day before ingestion time. So if a trip updates 2 or 3 days later, you'll get that updated trip. So there will be a concept of ingestion time and actual wall clock time for a device. So. Yeah, so we're right now working on, so one of the final things we need to work on here is it's pretty easy for us to push the data in, but we're looking at what are the pieces of the puzzle here that we need two-way communication. One of the nice things is Bigquery, although it's a big data infrastructure, it actually behaves a lot like a relational database. So it has the concept of updates and inserts and deletes. And so we can take advantage of that. It's just a matter of making sure we get those messages from my Geotab. And we aren't using the feeds to do the initial data dump, so maybe there's some new feeds we need to create to do this. Yeah. Yep.
How long does it typically take to do an analysis like you did with the large retail customer?
So I could say it would take me less time now than it did then. That was over the course of a few months, but there was a lot of learning going on there. So our hope is that some of the sample code that we provide would be able to jumpstart this type of analysis. The bottleneck is certainly not on the data tool side. The bottleneck was for that particular one was really coming up with the different things that we'd like to slice and dice and see, and collaborating with the reseller and the customer to figure out what that might be. But our plan is, if we are doing these types of engagements, we'd like to make our learnings from that available to anyone on this package. So I would say, again, I guess it depends on the acumen of whoever's doing the data science on your side, but running those types of scripts, if data was in a particular format and we could provide those scripts, would be minutes to hours to generate something, and then maybe visualizing it might take you a little bit of time in whatever tool you have.
And like any big data problem, it all depends on the cleanliness of the data as well. You know, obviously we try and keep the data as clean as possible that we're pushing to Google BigQuery. But if you know we are, or if you're uploading reports that are really messy fields, it's going to take longer to go through that data and to get it cleansed and workable. So it is kind of a unique for each case, but that's what we want to give people guidance on too, right? Through some of these how-tos in terms of how to structure the data, how to spend your time, less time kind of worrying about cleanliness and just getting it up to BigQuery so you can focus on getting the results. There's another question here. Cost for items discussed. All no cost? No, it is not no cost. We don't have a price package for the data science package yet. So we're still working on that, but at this point, it will not be at no cost.
There is an upfront infrastructure cost for Geotab to do this, and we're not looking to make money in the kind of beta period here in this kind of first year or so. I think, Mike, was it first year or so?
First year introductory
Yeah.
pricing that will be flat rate across everybody. So whether you have 500 or 3,000 or 10,000 vehicles, it'll be the same price, but that will be disclosed to the reseller network next.
Would you be willing to provide a reseller just to their database so they can demonstrate the power to their customers?
That's a good question. So as we figure out this kind of first year model, we'll have to give that some thought, whether it's giving a reseller access to that or providing some sort of demo.
Or have demo.
Some sort of demo. Those are kind of ideas that we kick around, but that's an excellent point.
Yeah.
Thank you.
Anything else?
Anything else?
We have at least one client that their data's truncated in Geotab. I'm assuming having been imported to the Bigquery system, it would hold.
Yeah, so we have, I guess a general rule of thumb is we confidently have 2 years worth of data. I think it's probably 3 years at this point. So, at some point we turned on this kind of big data environment and started funneling things in. Going back beyond that is more challenging, but that is kind of the starting point. So if they're truncated, so I believe the customer I worked with would have been truncated as well.
Yeah. Yeah.
Will additional vehicle miscellaneous fields be available to pivot data? Let me think about this. So like make, model, year would be there. If it's like vehicle specific, engine type, and things like that, we haven't. I don't know if we've given that thought at this point. It would be anything we could bring back from our VIN decoder. Might be kind of interesting.
Yeah.
Any and all status data, like I think we're somewhere in the neighborhood of 30,000 different status data bits would be there as well. So whoever asked this question, it came in anonymous. If there's something in particular you're looking for, just come find me and let me know, or yell it out, and it's something we can put on our radar.
One of the information I was curious about for Neil's presentation this morning is in regards to the OEM's like diagnostics history, for example. Are those at any point will there be some data not available for public release or to release to us because it might whether compromise a relationship with an OEM or and I'm talking for example, the best example was the fuel data that Neil discussed this morning where he praised via Volkswagen, but he said a lot of them were cheating as well.
So I guess to be clear, we're talking about in this case like my Geotab data. And so if you had a fleet that had every make and model and enough of every make and model, that's your data. And if you wanted to do that same type of exercise, you would be able to do that exercise. So anything and everything that you're getting in my Geotab should really be fair game here. You have access to the APIs in my Geotab to really pull out any of this stuff. To be frank, you could set something like this up yourself using the APIs, and people have, and it's been successful. This is really just a shortcut that uses some of the tools that we think are great tools to use. So I guess the answer is if it's in my Geotab, you should be able to get it here.
Yeah. I mean, ultimately, we're trying to do some of the heavy lifting for you guys. We've done this already. We've gone through these exercises, and this is something that we know has value, and that's what we're trying to do. So we're trying to give everybody kind of a head start into that data realm.
Cool.
Excellent.
Excellent. I think we're almost out of time anyway.
Yeah.
So, like, I'll be around on the floor. Dan will.
Yeah.
There's members of our big data team scattered throughout the floor. Happy to chat with anyone. And thanks for making the trek all the way to this room to
Yeah.
listen. Thanks.